Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you have not yet subscribed, please kindly subscribe for us to build the mathematics community. In this lesson, we are going to look at how to find where a function is increasing or decreasing. Then we also find the relative maxima and minima of a given function, and we also look at where the function is concave up or concave down. The function that we have on the board is a polynomial function, and it is not a rational function because it is not a over b. Okay, so this function, let's see what happens. We have to find the point at which f of x equal to 3x to the power 4 minus 2x cubed minus 12x squared plus 18x plus 15 is increasing or decreasing. Then we have to find its relative maximum and minimum, and also the point at which the function is concave up or down. So let's see. For the function, let us find the first derivative. F prime of x equals 4 times 3, 12x cubed, 3 times 2, minus 6x squared, 2 times 12, minus 24x, and if you differentiate 18x, you get plus 18. The derivative of a constant is 0. Now, you find the first derivative. Now, let us find the critical points of the first derivative. Now, at the critical point, f prime of x equals 0. So, if we put this equal to 0, you have 12x cubed minus 6x squared minus 24x plus 18 equal to 0. Now let us reduce this equation, but we can divide through by 6. So if we divide here by 6, we get 2x cubed minus x squared minus 4x plus 3 equal to 0. Now this is a cubic function. So let's try and put in some values of x to check if you get a factor. Now let's put in positive 1. If we put in x equal to 1, we're going to have 2 times 1 cubed is 1, minus 1 squared is 1, minus 4 times 1 is minus 4, plus 3, and 2 times 1 is 2. So this will give us 0. Very simple as that. This implies that x minus 1 is a factor of this cubic function. So let us divide this by x minus 1. So 2x cubed minus x squared minus 4x plus 3 divided by x minus 1. I reduced it. If you like, you will not reduce it and you will just test your values here. So x will go into 2x cubed, 2x squared, x times this will give us 2x cubed, negative 1 times 2x squared will negative 2x squared. If we subtract this, we get 0. If we subtract it, we get positive x squared of minus 4x plus 3. X will go into this positive x. X times x will give us x squared. Negative times x will give us negative x. So if we subtract, we're going to get negative 3x plus 3. X will go into negative 3x, negative 3. X times this will give us negative 3x. Negative times negative will give us positive. So if we subtract this, we get 0. This implies that we are going to have 2x cubed minus x squared minus 4x plus 3 to be equal to x minus 1 times 2x squared plus x minus 3. Very simple as that. So this is quadratic, so let's simply factorize that. We have x minus 1 times 2 times minus 3 is minus 6. So factors of minus 6, if we add to get positive 1, we have 2x cubed minus 2x plus 3x minus 3. You have x minus 1 times 2 into brackets, 2x bracket x minus 2 is x minus 1 plus 3 into bracket x minus 1. And we will have x minus 1 times 2x plus 3 times x minus 1. So we're going to have x minus 1 squared times 2x plus 3. Wow. Equal to 0. Very simple as that. So we are going to have x equal to positive 1 and x equal to negative 3 divided by 2. Now, these two values of x will now give us some intervals. So let's look at the interval. So here we're going to have negative infinity to negative 3 on 2 as one interval. Then you have negative 3 on 2 to positive 1 as another interval, and then we have positive 1 to positive infinity as another interval. So what do we do within these intervals? So within this interval, we're going to check f prime of a number within this interval. So here within this interval, you can have negative 2 here, or this is negative 1.5. So if you go to this side, negative 1.5. So it means that negative 2 is here, negative 3 is here. So you can check from negative 2 going. And within this interval too, we can check f prime of 0. Because this is positive 1, so 0 will be there. And within this interval, you can check f prime of positive 2. So let's do the check. I think I've done that one here to make the video very, very short. So if you check f prime of negative 2, you're going to get minus 54. So put negative 2 into this. Put negative 2 here. If you put negative 2 into this, you're going to get minus 54. And minus 54 is less than 0. If you put f prime of 0, if you put 0 here, 0, 0, 0, you get positive 18. And this positive 18 is greater than 0. If you put 2 here, positive 2 here, we are going to get 42. We're going to get 42, and this 42 is greater than 0. Very simple as that. So let's use the calculator to cross check. I have 12 into bracket 2 keep minus 6 times 4 minus 24 times 2 plus 18. Yeah, the 42 is correct. So now what do we see here? So if we come here, you've seen that any value within this interval will be negative. So here, the function is decreasing. We are getting negative values. So it means what? The function f of x is what? Decreasing. So the function is decreasing on this interval, because f prime of any value within this interval will give us negative value which is less than 0. So it will always decrease. You can put in negative 3 and c. You see that it will go down. It will still decrease. Now, here, what do we see? 18 is greater than 0. So the function is increasing here, right? It's increasing. And here to 42 is greater than 0. So here too, it is increasing. Very simple as that. So the function is decreasing on this interval, and it is also increasing on these two intervals. Wow. Now, how do we find our relative maxima and minima? How do we find that? Now, to find the relative minima or the relative maxima, we will look at where on the interval f prime of 1 changes sign from either positive to negative or negative to positive. So now, you see that if we look at this interval, from negative 3 on 2 going, the function changes from negative to positive. Wow. That is, if you put in any number greater than negative 3 on 2, the function will start increasing. So the function changes from negative to positive at this point, negative 3 on 2. Very simple as that. So you put in any value greater than negative 3 on 2, you see that you will see that you get numbers that are what? Positive. Let me repeat this. If you put in any value of x greater than negative 3.2, you can check for this. Negative 3.2 is just negative 1.5. You can check negative 1.501. Put it inside this, and you see that you get a positive value. You can put in 0.00001 because this is greater than negative 1.5. Sorry. This one is even less because it will go this way. Sorry. This one is negative 1.5. So you have negative 1.4. Yes. You have negative 1.4 here. That's negative 1.4999. Yes, it's on this side. Rather, it's not negative 1.50. That one will go to this side, or it will be increasing. So here, if we check numbers that are greater on this side, on the right side of negative 1.5, the function will start to do what? Increase. The function will start to increase. Because here, if you have negative 1.5, we move from negative 1.5, negative 1.4, negative 1.2, negative 1.1, negative 1. Then we go to 0. Very simple as that. So we are saying that f of negative 3 on 2 is the relative minima. Is the relative what? Minima. Is the relative minima point. At this point, that is the smallest point at which f prime of x will be less than 0. If we move from that point, that is values that are greater than this number, the function will start increasing. So now we put negative 3 on 2 into the original function and find the relative minima point. So if we put in negative 3 on 2 into this, we are going to get negative 273 on 16. I've done that one already. Yes. Very, very simple as that. So Put in negative 3 on 2 into this, and you are going to get the relative minima as this. So the relative minima, negative 2, 7, 3, occurs at x equal to negative 3 on 2. Very, very simple as that. Now, do we have a relative maxima? No. The relative maxima is the point where f prime of 1 changes from positive to negative. So here is positive, positive. So the function does not change from positive to negative. So we are not going to get any relative maximum. Let me repeat this important point again. Here the function changes from negative to positive. Here from positive we are still on positive. If it had changed from positive to negative, then we would have a relative maxima point. For instance, if we have had here as, let's say, negative 42, so we see that negative 42 will be less than 0. If this had been our answer, then we would have said that this positive 1 is the relative maxima point, because at this point the function will change back to negative. But that is not the case. We are still in the positive zone. So it implies that this function has only relative maxima, relative minima, but no maxima point. Okay, now let's move to the concativity. For us to find the point at which the function is concave up or concave down, we are going to use the second derivative test. So let us find the second derivative of our function. Now, f prime of x equals, if we differentiate 4x cubed, we get 36x squared. If we differentiate minus 6x squared, we get minus 12x. If we differentiate minus 24x, we get minus 24. If we differentiate positive 18, which is a constant, we get 0. Now let's find the critical points. We have f prime of x equals 0. This implies that 36x squared minus 12x minus 24 is equal to 0. Wow, that is very simple. Now, we can divide 2 by 12 to get 3x squared minus x minus 2 equal to 0. And this is a quadratic equation, so let's factorize it. We have 3x squared minus 3x plus 2x minus 2 equals 0. So we have 3x into brackets x minus 1 plus 2 into bracket x minus 1 equal to 0. We have 3x plus 2 times x minus 1 equal to 0. This will give us negative 2 on 3 or positive 1. So this one too will give us intervals. So let's draw the intervals here. So it means that we're going to have the interval from negative infinity to negative 2 on 3, and then negative 2 on 3 to positive 1, and then the interval from positive 1 up to positive infinity. Okay, so now let us test values here for f prime. So within this interval, we can take negative 2. Negative 2 is there. Within this interval, we can test for f prime of 0. And here we can test for f prime of positive 2. Wow. So I've done that one here already. Yes, on this sheet. So let's look at that. Yes. This one, I even used negative 1. So just go to the second derivative. And what is the second derivative? This is the second derivative. Whether the one that we've reduced, this one or what we've reduced, to give you the same thing. So if we put in negative 1, negative 1 squared is positive, so this will give us 36. If you put in negative 1, negative times negative will give us positive 12 minus 24, which will eventually give us 24. So here you have 24, which is greater than 0. And here if you put in 0, this will be 0, 0, and you'll be left with minus 24. So minus 24 will be less than 0. And here if you put in positive 2, we are going to get 96, which is also greater than 0. So here, what do we do? Since here f prime prime of x is greater than 0, then the function is concave up. Here it is less than 0, so the function is concave down. And here f prime prime is greater than 0, so the function is concave up. Very, very simple as that. Very, very simple. Very, very, very simple as that. Thank you for watching. Please subscribe, like, share, and leave your comments. Bye-bye.